Okay, we're looking at LSAT 64. This is October of 2011, Logic Game 2. A government needs to assign new ambassadors to V, Y, and Z. The candidates for these ambassadorships are J, K, L, N, and O. One ambassador will be assigned to each country, and no ambassador will be assigned to more than one country. Okay, so what on earth does that mean? Well, we know that we have 3 countries and 5 potential candidates. We know that only one candidate can occur in each one of these countries, and no candidate can occur more than once. So basically what we should understand is that of these 3, only 3 of these 5 can occur. Okay? And then what you have to ask yourself, is there any inherent order with V, Y, and Z other than, I guess, the alphabetical nature of it? And there's not. It doesn't matter what order we place V, Y, or Z. So we know that we're dealing with a grouping game. Now, we don't know if there are sequential aspects to the game. The only sequential aspect we could have is if there's some rule that comes up that says, you know, Z elects first, something of that nature. But we don't have that right now, and that actually never comes up in this game. So what we're dealing with is just a straight up grouping game. And our groups are V, Y, and Z. Okay? All right, so let's read on. The assignment of the ambassadors must meet the following constraints. Either K or N, but not both, is assigned to one of the ambassadorships. Okay, so it's K or N, but not both. I put the underline there to indicate the exclusive or. So what we know is that within V, Y, and Z, either K or N, but not both, must occur. Okay, the next rule, if J is assigned to one of the ambassadorships, then so is K. So if J is elected, then K is as well. Okay, and if K is not, then J cannot be. Okay. The third rule, if O is assigned to V, then K is not assigned to Y. So if O is assigned to V, then K is not assigned to Y. And if K is assigned to Y, then O cannot be assigned to V. And then the last rule says if L is assigned, then it must be assigned to Z. So if L is assigned, then L must occur with Z, which means that if L is not with Z, then L does not occur. Suffice it to say that if L occurs, L must occur with Z. Okay, so as always, we want to utilize the hierarchy of rules to solve the scenarios. And we would think that, you know, we're basically given, you know, this is what I would classify it's a distributive rule. It's a first order rule because we know that one or the other must occur, but it creates 6 different scenarios, so it's kind of a strange first order rule in that respect. But we do know that you know, that one or the other must occur. Okay, and so that does tell us something. Other than that, we're just given all conditional statements. All right. So, but we can solve the scenarios in this logic game. There's only 7 different things that can happen. And so let's just begin and see what we come up with. We know that K or N must occur. Okay, so if we know that K has to go like this. Okay, and then if we come over V, Y, and Z, we know that N would have to occur in this manner. Okay, so that's all that can happen with regard to K and N. Let's just think about if we just place these variables down here, J, K, L, N, and O. Well, we know that N's used up, right? And we'll do the same thing with K. K is used up. Now, the thing is both can occur, so we know that K and N are both used up. So K and N are done. We've wholly solved whatever can happen with them. Now let's just look at this side for a minute. Now, we know that if K does not occur, then J also can't occur, so that's out. All right, so we're just dealing with L and O with regard to this. And what do we know about L? If L occurs, it must occur with Z. So if L is going to occur, it must occur with Z. That means here, this is out. All right, so this is out. We've exhausted L, and the last thing we're left with is O. So that's all that can happen with regard to a situation where N occurs. There's only 2 things that can happen. Let's go ahead and look over at this side. And let's just think about the bottom one here, okay? When we know that if L occurs, L must occur at Z. So when K is in Z, L's out. So we're just left with J and O. And let's think about what can happen with J and O. The only rule that we have, we know that if J occurs, K must also occur. Since K is already here, it doesn't matter if J occurs or J doesn't occur, but if J does occur, we have satisfied this condition. So this is good to go. Let's look at this, though. The only other thing that we need to look at is the confining characteristic with O. If O is in V, then we know that K can't be in Y. Well, here K is in Z, so this rule has no bearing on anything. Long story short, J and O can occur in either place, and there is no rule violated. Okay, let's take a look at what happens when K is in Y. No pun intended, by the way. If K is in Y, then O cannot be in V. So right here, we know that O cannot occur here. That means that O is out. Okay, O has been used up. We're left with J and L. Okay, so we place, and we know that an L can occur here. Okay, and then what does that leave us with? That leaves us with J. Okay, but there's one other thing. O can't occur here, but what happens if we place O here? Okay, there's nothing against that. If we do place O there, we've used O up, and we know that L cannot occur, so we end up with this. Okay, now let's just take a look at what can happen with the last part up here. We can place L in Z or not in Z. So we'll just use L here, and then we'll carry this K down. We'll carry this K down. Okay, so now we have K and N used up, and we also have L used up, and we're left with J and O. Here, J or O could occur. Again, we know that if J occurs, then K must occur, so that condition's satisfied. And we know that the only rule dealing with O is if O is in V and O is not in V. So there's nothing against this right here. And again, the same thing here. We just know that there's an option, and we have a J and O. Okay. Okay. J, O, and KY. Strange bedfellows with the LSAT test makers. All right. So, anyways, we are left with 1, 2, 3, 4, 5, 6, 7 scenarios. They are wholly solved. We have a couple of options here, a couple of options there, but we can answer any question given with relative ease. So let's go ahead and go to the questions. Which one of the following could be the assignment of the ambassadors? Okay, so this is a rule based question. All we want to do is go through the question, I'll go through each of the rules, figure out which answer choice breaks that specific rule. That answer choice is eliminated. The last answer choice standing is, of course, the correct answer. Okay, so if we look at the first rule, okay, K or N, but not both, must occur. Okay, and if you look at D, K and N both occur, so D is out. Let's take a look at the second rule. If J occurs, then K must occur. The second rule, if you look at A, if J occurs and J does occur, K doesn't occur, so A is out. I don't know if I said that correctly. If you look at A, J occurs, but K does not occur, so A is eliminated. So now we're just looking at B, C, and E. Let's look at this rule. If O occurs in V, then K cannot occur in Y. And if you look at Rule 3, if you look at E, this is Rule 3. If you look at E, O occurs in V, okay, and K does not. K does occur in Y, so that breaks this. So E is out, and we're only looking now at B and C. And the last one, the last rule we have, or the fourth rule we have, is if L occurs, it must occur in Z. And if you look at C, L actually occurs in V, so C falls out, and we're left with answer choice B. Okay, let's look at 8. The pair of candidates who are not assigned to ambassadorships could be. So basically this question asks us, between the two people given, can you show me an example where neither one of them have got to be in an ambassadorship? So let's look at A. Could it be that J and N both don't have to occur? And it happens right here in the first scenario. You could have K, O, and L. That is sufficient. That is the answer to the question. It is not the case that J and N both must occur as ambassadors. Therefore, A is the correct answer to the question. Let's look at B, though. J and O. Well, here either J or O would have to occur. Here both would have to occur. J would have to occur here. J and O, actually. J and O, and then O and O. So it cannot be the case that neither J nor O would not show up. Okay. Let's look at C. K and L. Well, K has to occur on this side, and L has to occur here. So that cannot be the answer to the question. Let's look at D. K and N. Well, we have K here and N here, so that cannot be the answer to the question. And then E. L and O. Well, we have O's here. We have L here. We have to have an O here. We have an L here. We have to have an O, and we would have to have an O there. So we know for a fact that A is the answer to the question. Again, J and N, it is not required that either one of them occur, and it happens right here because we could have K, O, and L. J and N are not ambassadors, and we have 3 different ones. So again, A is the correct answer to the question. Let's look at 9. If O is assigned as ambassador to V, then the other 2 ambassadors assigned could be. Okay? Well, where do we have O assigned to V? Okay? O assigned to V happens here, and that would mean we'd have J and K. So we'd have, it's possible when O is assigned to V that we have J and K, and also here, O is assigned to V, we could have N and L. Okay? So we just look for J, K, or N, L. And we don't have J, K. We do, in answer choice E, have L, N. This is the correct answer to the question. It is E. Let's look at 10. If K is assigned as ambassador to Yemen, then which one of the following must be true? So where do we have K assigned to Y? It's right here. And it doesn't happen here, so we're looking only at scenarios 3 and 4. So which one of the following must be true? J is assigned to V. Absolutely, that has to be the case. That is the correct answer to the question. Let's look at B, though. L is assigned to Z. Well, it could be, but it doesn't have to be, because O could be there. So that's not a must be true. Let's look at C. O is assigned to Z. Same thing. L could be assigned to Z. Let's look at D. J is not assigned to an ambassadorship. Well, no, that is absolutely not true. J must be assigned to an ambassadorship. And then E, O is not assigned to an ambassadorship. That it doesn't have to be true. O can be assigned, but it doesn't have to be assigned. So that is not true. That is not a must be true either. Again, the only must be true is A, that J is assigned to V, and that must happen. Okay, let's look at 11. Which one of the following cannot be true? A, J is assigned as an ambassador to Z. Well, it could happen right there. So because it could happen, it is not a cannot be true. Therefore, it is not the answer to the question. Let's look at B. K is assigned as ambassador to Z. Well, that could be true also. Therefore, it is not the answer to the question. Let's look at C. N is assigned as ambassador to Z. That cannot happen. That does not happen here. And if you look right here, it does not happen here either. It cannot happen right there. Okay? So C is the answer to the question. It is impossible for N to be assigned to Z. Let's keep going, though. D, L is not assigned to an ambassadorship, or L has to be here. It's right there. L does not have to be assigned to an ambassadorship. So it could be true that L is not assigned, because again, it happens in scenarios 4 and 5. Therefore, that cannot be the answer to the question, because it's asking us what cannot be true. Let's look at E. O is not assigned to an ambassadorship. Well, if you look at scenario 3, O is not assigned to an ambassadorship, therefore that could be true. As such, it cannot be the answer to the question. Okay, let's look at 12. Again, the answer to 11 was C. We proved that. Let's look at 12. Which one of the following, if substituted for this constraint, that if J is assigned to one of the ambassadorships, then so is K, would have the same effect in determining the assignment of ambassadors? So we're saying we're going to get rid of if J, then K, and see, and we're going to replace it with another rule and see if we can have the same effect. Okay, so there are two steps in this process to efficiently solving these. One is you just want to apply the rule that's the answer choice that's given and see if it actually somehow breaks one of these scenarios, okay? And if it breaks it, then it cannot be the answer, okay? And then if one doesn't, we move through. If we only end up one that doesn't break any of these scenarios, that's the correct answer to the question. If we end up with two, we need to think about it a little bit more deeply. So let's just go through and see what we got. If K is assigned to an ambassadorship, then so is J, okay? Well, right here, if K is assigned, we could have an O, okay? So right there, that cannot be the case. That actually breaks one of the examples of the scenarios, so that falls out immediately. It's very simple to eliminate that one. Okay, let's look at B. If L and O are both assigned to ambassadorships, then so is N. Okay, so we're just looking right here. If L and O are assigned, then so is N. So that doesn't break anything. But here we could have L and O both assigned, but with K assigned. So that absolutely breaks one of the examples or one of the scenarios. So it's out. So B falls out. Let's look at C. If O is not assigned to an ambassadorship, if O is not assigned, then K is, okay? Well, here O is assigned. O would have to be assigned here and here. 3 is the only place so far that O isn't assigned, and O could also not be assigned here also. We'll check it out. If O is not assigned, we actually do have K occurring, so C actually does not break the scenarios. All right, so C is a possibility for us. We checked that one, okay? Let's look at D. Hopefully, that's the only one that doesn't break the scenarios, and we know that's the answer to the question. It's not going to be the case here. We're going to have to think about it more deeply, but we check it off and we go to D. Let's look at D. If J and N are not both assigned, J and N cannot both be assigned to ambassadorships. Well, that doesn't happen here, and then we know for a fact that there's no N on this side. So D, like C, does not break any of the scenarios. So far it's between C and D for us. Let's look at E real quick. N and O are not both assigned to ambassadorships. Well, that just breaks these scenarios right here. So we know for a fact that E's out. So long story short, we're between C and D. And if you're not trying to get a 173 on the LSAT or whatever, you could at least get down to this and make a, just guess between the two. But typically you're going to be able to eliminate 3 pretty quickly, and it's going to be between these two. So let's go back to C and think about what is going on here, okay? First off, if O is not assigned to an ambassadorship, then K is. Well, on this whole side, all right, we've got K, all right? So no matter what happens over here, we cannot disrupt anything over here. But I want to look over here, and let's think about what's happening here. So if O is not assigned, to an ambassadorship, then K is assigned to an ambassadorship. So we have if O, then not K. And what it is we're trying to replace this rule, if J, then K, or if not K, then not J. And where we started this whole statement out, J, K, L, N, and O, well, we know we used N, right? Because that's where N came from, and we could not use K. Now, we used to say, because we didn't have a K, we cannot have a J. But now that we've gotten rid of this rule, we have this rule. If there's not an O, then there must be a K. So let's just operate. All right. We know for a fact if there is no K, then we must have an O. All right. So we know for a fact that O would have to occur. wherever it occurs. It doesn't really matter where it occurs. And now we're just left between J and L. Okay, what that means is there's nothing that prevents J or L from occurring. Okay, I mean, we could even put, we know that we could put these variables literally anywhere. It doesn't matter. I'm not trying to place these in any specific group. The point is that with this rule, okay, we know that if N occurs, we would end up with O, that's for sure, but there's nothing that prevents J from occurring. Therefore, C is not the correct answer to the question. It does not have the effect that we're looking for. Now, let's look at D, though, and it says J and N are not both assigned to ambassadorships. Okay, let's think about this for a minute. We've got K's all over here, and we know that if J occurs, then K has to occur. So it doesn't really matter what happens over here. If J ever occurs over here, then K is there. And because K and N cannot occur, we're never going to have an N on this side. It's never going to happen. All right, so the bottom line is anywhere that J occurs on this side, we've already got a K, so that's fine. We're just focused back to this side. And it says, and the rule says, if N occurs, then J can occur, or J and N cannot both be ambassadors. So we are back to this situation, all right? Right now, we're here, okay? And if N occurs, and I'm crossing out N because I've used N up, and I know that K can occur because of this rule. And this rule says that if J occurs, J and N cannot both be ambassadors at the same time. So we slice that one out, and we are now back in the same exact place as the rule, if J, then K. So as such, D is the correct answer to the question. Now these last questions are, I find them to be more complicated, obviously, than other questions that you're asked during the logic game. Just remember, the first step in looking at these is just go through and see if any one of these rules just violate one of the scenarios that you've created. And then when you get down to the ones that have not, then you have to think about it a little bit more deeply. Okay, that concludes LSAT 64 October 2011 Logic Game 2.